Hey there, guys. I am ever so sorry that I'm gone again. I'd say that I'm surprised at how sick Nola's been this spring, but seems to be a pattern for her. She developed a case of pink eye here today, so there's no way for her to go to school tomorrow. So she's had a pretty rough night, so I'm pretty exhausted already, but got to get this done. And you should have a note sheet from the sub. And great thing about what we're doing today is really it's gonna be just an extension of what we did yesterday. So most of what we do will be, just the same thing. Also, we using the, find our p's and q's and using the calculator to find that good answer that we're going to guess, take out of there, and then solving from there. Just that the answers are going to get a little bit messier. Just kind of like we started seeing yesterday, some messy ones. Just kind of finishing up that mess today. So this will be the last version of this stuff, and then on Thursday and Wednesday we'll do something different. But as we kind of wrap up this unit, so I do want to look at a couple things real quick before we get going on that other stuff, though. So just a couple of quick problems to solve. So I want to solve A here, and this is pretty similar to one we did yesterday. So it's that idea that there's only one x in the problem, so we should get an x by itself. So I want to add 35 to both sides. And divide by 5. So x squared equals 7. And then we want to square root both sides. So we get x equals the square root of 7. And then just, like we talked about yesterday again, that whenever you square root, there should be two answers, positive answer and a negative answer. So there's that too. So x equals positive negative square root of 7. Pretty easy. Then looking at the next one, so kind of the same fashion, we want to get x by itself, so I'm going to subtract 18 here. So that gives me 2x squared equals negative 18, and divide by 2. So x squared equals negative 9. And then when we go to square root, so x equals plus or minus. So what's the square root of negative 9? I hope you were all saying 3i. So remember, when we square root negatives, we get imaginary numbers. So that's coming back. Okay, so a couple of quick solving equations. That one like one we did yesterday, one with the imaginary numbers here. So that will be something that we're going to see a couple times today. So just wanted to bring that back to your memory here. And then this third one here, we're going to solve using the quadratic formula. So this is that idea that what happens when we can't use the AC method. Again, just the kind of reason why there. If we think about what our AC is, our A times C is 6. And we would need that to, actually, sorry, let's just go ahead and use the quadratic formula and see what happens. I don't want to waste time doing that. So we need to know what that is. So it's negative b plus or minus square root b squared minus 4ac all over 2a. So our a value being 2, b value being negative 7, and c being 3. So x equals, don't forget to write the x equals negative. So b being negative 7 plus or minus, so make sure you have negative negative 7. Plus or minus square root, so negative 7 squared minus 4 times 2 times 3, which is c, all over 2 times 3. Not 2 times 3, 2 times 2. Wait. Like I said, I'm tired. Alright, so x equals, so negative negative 7 would be positive 7, plus or minus square root. 7 squared is 49. Negative 4 times 2 times 3, so that would be 8 times 3, which would be 24. So minus 24 all over 4. So that'd be 7 plus or minus square root. 49 minus 24 is what, 25? And so for this particular problem, I think because that problem was factorable, we can go further. You know, a lot of times they end up stopping there. But so, you know, x equals 7 plus or minus, and the square root of 25 is 5, divided by 4. And so this would be that point where the problem would end up splitting into two problems because we can finish this. You know, so what's 7 plus 5 divided by 4, which is 12 divided by 4, which is 3. And then what's 7 minus 5 divided by 4, which is 2 over 4, which is 1/2. So those would have been the solutions we would have gotten if we had factored it. And but again, a lot of times the problems end up stopping, you know, at this point because we can't go any further. And so we're going to see some answers kind of like this today. So just kind of keep that in your back pocket. Be looking out for our eyes. Be looking out for you know, what happens if we can't factor it, and so how do we do from there. So all right, so let's jump into that. So this fundamental theorem of algebra, this is something we've actually talked about quite a few times. Probably every day for the last many weeks we've been, you know, talking about this. It means that any nth degree polynomial, so what's the degree, right? So based off that highest exponent has exactly n zeros. So this third degree polynomial has exactly 3 zeros. So the highest exponent tells us how many zeros there are. So a fourth degree polynomial would have 4 zeros. So we've been talking about that. That's something we've, right, no biggie. So fundamental theorem of algebra though, right, that means it's a big deal. Right, so if we think about this, right, when we're done here, we should have, with finding the zeros of this guy, we should have 3 zeros. So 3x equals, and I've gone ahead and already put the sketch in there, but let's go ahead and start by where we should start with, those are our p's and q's. And so thankfully this one's pretty simple. Our p value is just 2, and our q value is just 1 from here and here. So factors of 2, factors of 1, so pretty simple. P divided by q, positive or negative, 1 and 2. So we're just looking at, you know, 1 divided by 1 and 2 divided by 1. So we should have, you know, rational answers that are either 1 or 2, or negative 1 or negative 2. So as we look at the graph, we definitely see, you know, it's hitting at 1. And so we're going to use that as our number that we're going to pull out of the, with the synthetic. So let's see, I'll lock that down now. So I'm going to take that 1 and pull it out with the synthetic. So I want to check for gaps. I do have a gap here, so this one has 0 x's in it, so make sure I notice that 1, negative 3, 0, 2. I don't think anything we saw yesterday had a gap in it, so bring that back. So 1 times 1 is 1, negative, so add, get negative 2, get negative 2 here, add, get negative 2, and then get negative 2 here, add, get 0. Right, so there's that 0 we needed. And so then this would be our constant, our x, and our x squared. So x squared minus 2x minus 2 equals 0. So if we try AC on this, let's see, our AC would be 1 times negative 2 would be negative 2, and then factors of negative 2 that add to be negative 2. Well, the factors of 2 are 1 and 2, and there's no way for us to add those together to get negative 2. So we definitely are not going to be able to factor this. So since we can't factor it, we're going to do quadratic. So I need to know what A is. A is 1, B is negative 2, and C is negative 2. So x squared equals negative b squared, so which is negative 2, or sorry, negative b square root of b squared, which is negative 2, minus 4 times. Alright, so an A is 1, and C is negative 2. All over 2 times A, which is 1. So negative 2 gives us 2, plus or minus square root. 2 squared is 4. And then negative 4 times negative 1 times 1 times negative 2 would be positive 8. All over 2 times 1, which is 2. So x equals 2 plus or minus square root 12 over 2. Remember, you're not allowed to reduce anything here right now because the square root of 12 hasn't been reduced yet. And so we need to sock that out, which is 2 times 6, which is 2 times 3. So we got a pair of 2's and then a lonely 3. So that would give us x equals 2 plus or minus a pair of 2's gets to come on the outside, and then the lonely 3 stays on the inside, and that's all over 2. And now that it is simplified, we can look at the 2's that are on the outside and we can reduce those. So our final answer here for x would be 1 plus or minus square root of 3. So, or 1 square root of 3, but you know, we don't need that 1 in front of the square root of 3. And then the 1 underneath, we don't need also. So, so those are our other two answers. So that's what would be, you know, these two numbers right here. So the square root of 3 is about 1.7. So 1 plus 1.7 would be about 2.7. We can see that happening there. And then 1 minus 1.7 would be about negative 0.7. So we can see that happening there. And then we have our 1, of course, that we took out originally. So don't forget your third answer there. So make sure you have all three answers. All right. And so that what that looks like. So kind of making sense of that problem. Let's look at the next one. So if we look at this, just kind of take a note of what we have right off the bat. So we should end up with 4 answers to this problem. I'm just going to start with our p's and our q's. So our p-value would be 72. That's kind of a big one. Thankfully our q is small though, so 72. So we got 1, 72. I'm going to write these out just in order this way, that way I forget something. Then 2 times 36, 3 goes in, 24 times, 4 goes in. Ooh, let's see, is that 18 times? 5 doesn't, 6 goes in 12 times, 7 doesn't, 8 goes in 9 times, and then 8 and 9, so. And then Q is 2, so just 1 and 2. Alright, so actually got a pretty decent sized list here for P divided by Q. Don't forget your plus minus. So I'd have 1, 72, 2, 36, 3, 24, 4 and 18, 6 and 12, 8 and 9. So a lot of these numbers are even, so when we go and divide them by 2 also, they're going to just reduce out, but 1 is not even, so we have 1 half. 3 is not even, so that'll give me 3 halves. And then 9 is the only other non-even number, so the only one that wouldn't reduce out. So lots of options there for our 4 zeros. And if we look at the sketch of the graph real quick, so if we sketch that out, you notice pretty easily those cross right there at 3 and negative 3. So we're going to do something that we did yesterday, which is to do 2 layers in synthetic. Since we do have a quartic, I want to get that down to a quadratic before I try to solve it and factor it or whatever if I need to. So so it doesn't matter which one you grab first. If you want to grab the 3 or the negative 3 first, it really does not matter. Do note that we have a couple of gaps here in this. We have 0x cubes. We also have 0x's. So make sure you're watching out for that. I'm just going to take the negative 3 first since it's on the left. It's the first thing I see. But it does not matter which one you do. 0, negative 10, 0, negative 72. 2 comes down. That gives me negative 6, negative 6. That would give me positive 18, which would give me 8, which would give me negative 24, negative 24, which would give me 72. Great. and then so there's my 0. And then, so that's, this guy here all done. So I'm going to take the 3 now, so I just build right on to where I was. Another box, get rid of that 0, put the 3 here, bring that onto the 2. So 2 times 3 is 6, which gives me 0, which gives me 0, which gives me 8. 8 times 3 is 24, which gives me that next 0. So check, check. All right, so there's our 3 and our -3 all moved out. And so we put the x's back in, remainder, constant x squared. So pretty similar to the ones we saw yesterday. We got this 2x squared plus 8 equals 0. And as we try to solve for x here, so I'm going to subtract 8 to both sides. So I get 2x squared equals -8. And then as we divide by 2, so that would give me x squared equals -4. And then as we square root, so x equals plus or minus, since it's the square root, and the square root of 4 is 2, square root of -4 is 2i. So this is why we don't see 4 x-intercepts on this graph. It doesn't do this, right? We don't have 4 points of contact because there's only 2 real solutions for this graph. The other 2 are imaginary, so that is why. And so there was a worksheet from a while ago that I pointed out this on, that we only saw 2 answers. We knew there should be 4. And so this is the why behind that, because the other 2 are actually imaginary solutions. So we have 2 real solutions and then 2 imaginary solutions. So there's our 4 solutions to that problem. So that's something we're on the lookout for when you graph it and it's not doing what you think it should, as far as how many times it crosses the x-axis. Well, it might be because there's imaginary solutions. So let's look at another one. All right, so this one's a little bit quicker on the get-go because our p and q are easier. So on this one, I don't think we've seen this before. P is 1 from here, and then our q is 2. So of course factors of 1 are 1 and 1, and factors of 2 are 1 and 2. So p divided by q, positive, negative. So 1 divided by 1 and 1 divided by 2. So easy peasy. So let's see how that matches up to our graph. So we sketch that out. Well, definitely seeing that 1 there. So that's going to be what I'm going to use on my synthetic. So that's easy enough. So 1, check for gaps, no gaps. 2, -7, 6, -1, drop to 2. Multiply, get -5, get -5. Add, get 1. Multiply, get 1, get 0. Alright, cool. So there's my remainder, my constant, my x squared. So 2x squared minus 5x plus 1 equals 0. That would give us an AC of 2. Factors of 2 that had to be -5. Definitely not. So we're going to go quadratic on this. So A is 2, B is -5, and C is 1. So x equals -b, so -5 plus or minus b squared, so -5 squared minus 4 times A, which is 2, times C, which is 1, all over 2 times 2, which was A. So -5 gives me +5 plus or minus square root. -5 squared is 25. And then -4 times 2 times 1 would be -8. All over 4. So it gives me 5 plus or minus square root of 17 over 4. So 17 will not suck out, so I don't need to worry about that. So really what that tells me is I'm done. These are the two answers I get. So that's going to be what, 5 plus the square root of 17 divided by 4 would be this thing out here above the 2. And this 5 minus the square root of 17 divided by 4 would be this thing out here, close to 0. Square root of 17 being just a little bit above 4. So, 5 minus 4 being 1, and then divided by 4 being 4. So we're going to have something just a hair over 1/4 here, and then this would be something a hair over 9/4, so 2 1/4, just a hair over that. So that's what those two answers are. And then, of course, we had our 1 that we took out originally. So there's our 3 solutions to that problem. All right. So we're kind of getting a feel for what these are going to look like, how this is going to play out. Last one, and we'll be done for the day. So looking at our P's and Q's here, so it's going to be a little bit messier. So P value being 36, and then our Q value being 3. So we got 1, 2, 3, 4, 6, 9, 12, 18, and 36 for all my factors of 36. And of course 1 and 3 for Q. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. And then 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 3 divided by 3 we already have. 4 divided by 3 is 4/3. 6 divided by 3 we have. 9 divided by 3, 12 divided by... And the rest we all have. So here's all our numbers that our P's and Q values, so our possible solutions. So let's look at the graph, see what we got here. So we only have 1 x-intercept here. We should have 3, so that should be a big clue that something's going on. I'm only seeing 1. It's somewhere between 1 and 0, so we kind of get rid of all the numbers that can't be, numbers that aren't between 1 and 0. So it only leaves 1/3 and 2/3, and it sure as heck looks closer to 1 than 0, so I'm going to have to guess this is probably 2/3. So I'm going to have to divide out that 2/3. Really don't have any other choice. So I'm going to put that 2/3 out here on the side of my box. Check for gaps. Do not see any. -2, 54, -36. So drop that 3. 2/3 times 3 is 2. And then add, we get 0. 2/3 times 0 is 0. Try to add to get 54. It turns out 2/3 times 54 is, well, what do you know? It's 36. So super duper. So there's our 0 we needed. So putting the remainder constant x squared. So we got 3x squared plus 54 equals 0. So, oops, dang. So what do I want to do with that? Just solve for x. So I get x by itself. So I'm going to subtract 54. 3x squared equals -54. Divide by 3. So x squared equals, what's that? 18. Yeah, so -18. And then we square root. So x equals plus or minus the square root of -18. Well, got to deal with that 18. So square root of 18 being 2 times 9, which is 3 times 3. So I got a pair of 3's, lonely 2. So x equals plus or minus. So that pair of 3's is going to come outside. But because it's negative, it's also going to get an I. And then the 2 is still inside, so... Ooh, sorry. All right. Well, there's the other 2 answers we could not see. Don't forget about that original one we did see, which was 2/3. So, just be on the lookout. That's kind of the end of this unit as far as this stuff goes. That, just kind of seen those messier answers, so those irrational answers and these imaginary answers, so the ones that don't show up on our list and the ones that don't show up on the graph at all. Definitely going to be things we will be tested over and using this quadratic formula and using what you know about square roots and negatives and stuff like that. So hope you guys have a wonderful Tuesday, and again, I'm super sorry that I wasn't there today. But Noel should be back at school on Wednesday. And there will be tutoring in the library after school if you're needing that. I know Miss Mills is there. Might be another teacher there to give you guys help. So definitely seek that out if it's something needed, or I'll be around Wednesday afternoon if you're needing help. So stop by and see me. Have a good day.